Lubricants themselves play a really key role in the automotive sector. In a race car, they are absolutely fundamental. The engine needs oil, it needs oil pressure, the gearbox needs oil, the differential needs oil, and in some situations the clutch also needs oil. The selection of lubricants we have across the market these days is absolutely vast. And they've all got their own benefits, they've all got their own weaknesses. And for us, the two key things that we're looking for are durability and performance. Chief really in our toolbox for guiding the decisions on which lubricants to use is the oil analysis service that RS offers. That allows us to look not only at the state of the lubricant in terms of its degradation and in terms of its contamination, but also in terms of the wear. What's happening inside that gearbox that we can't see from the outside. These performance and durability metrics that we're looking at in terms of the life of the oil are really critical in motorsport. One of the things that we're not so concerned about is the cost of the oil. We change oil very frequently and we use very little of it. In an industrial setting, perhaps that's not the case. And if you can look at the oil and you can see exactly when you need to change it, if you can increase that lifetime of that oil across a huge production line, you're drastically reducing your lubricants cost. And so for you, in the production context, if that's your area, it can be a really key thing to control your budget. The process for us to take an oil sample is really straightforward. In terms of the timing, we're always going to be doing this after a race when the car gets back to the workshop. That gives us the best possible window on seeing how that car is wearing and how that lubricant is aging. We're going to change the oil anyway, so we do a small drain sample that goes into a test tube, pop it in the post, and a couple of days later we get the results emailed through. This process almost gives you a crystal ball into what's happening inside that mechanical device. It gives us the ability to predict failures that haven't yet happened. We can look at the results of this oil analysis and we can see the types of metal, particularly the particulates that we're having out of this analysis sample, and we can, knowing the architecture of that mechanical device, we can tell where within that device that failure is about to occur from the type of metal that we see in those results. What I've got here is a few examples of some components that were removed from race cars over this last season that were removed as a direct result of what we found in the oil sampling analysis reports. What we're looking at here is some of the wear and some of the failure on the surfaces of these gears. And so seeing this failure internally is a very difficult thing to do. The oil sample analysis service is just something that gives us a real window into it. And we can see here, if you look, we can see the wear on the face of these teeth here. And of course, you're not going to know about this until it becomes a problem. We can deduce from this a couple of things. Firstly, that there is this accelerated wear on the teeth, but also that perhaps the change interval for the oil that we're using in this gearbox wasn't short enough. Wear like this, the pitting on the face, this can often indicate that the extreme pressure additives that are in the lubricants are breaking down and not doing their job efficiently. You can see a similar kind of thing with this. This is part of a differential, and we've got the galling around here that was indicative of the bearing surfaces breaking down and causing some movement in the diff. Again, it's not something that you can really pick up on in an inspection without completely stripping down the gearbox and the differential every time. You really can't see this wear. The same here on this dog ring for the gearbox. You can see excessive wear along the edge of the teeth here, which can be a problem. When they start wearing like this, you end up with fatigue lines through it, and you end up with these parts cracking off, which not only then become an issue for the shifting itself, but the broken pieces of these parts can then find their way into other areas within the gearbox and potentially the engine too if it's combined. Another failure that we managed to find through the oil analysis was contamination of coolant within the oil system of the car. This indicated to us that there was some discrepancy with the head gasket tolerances perhaps, or that there was a failure somewhere in the cooling jacket. And that showed up here. If you look, we can see on this graph here that there's two results previous to the failure result. This one shows relatively low levels of wear metals within the oil. And again, on this second test, relatively low levels. What we see then on this third test is a real high spike of borate. There's only a couple of places within a vehicle where we find borate. One of them is in the cooling system, one of them is in the brake system. Obviously, there's not going to be brake fluid in the engine oil, so we can deduce from that we had a head gasket failure. It was great for us to be able to get that before it became a problem. It enabled us to finish the race because we managed to replace the head gasket. It also enabled us to get to the end of the race without blowing the engine up. That covers the basics of how and why we use oil analysis in a motorsport setting. Don't forget to like and subscribe for more engineering insights.